welcome back to Passionate World Talk Radio. Educate, enlighten, entertain. And this afternoon on Cool Your Heels with Lillian, our special guest is Dr. Edgard Rivera-Valentin with the University Space Research Association. And today we're going to be talking about finding salt in the water on the planet Mars. So good afternoon. How are you doing today?
All right, thank you. I hope you're doing great.
I'm doing pretty good, too. It's very warm. It's around 80 degrees over here in Pennsylvania.
Just about the same here in Texas.
Really? Usually in Texas, this time of the year, it's a little bit warmer, but okay, so we're on the same temperature. Doctor, could you please tell everybody a little bit about yourself so they have an understanding of your expertise in the space research?
Sure. So I'm Edgard Rivera-Valentin. My PhD is in space and planetary sciences. My research focuses primarily on two parts in planetary science. One of them is planetary defense. So that involves observations of near-Earth objects with the Arecibo Radio Telescope in Puerto Rico to track them and characterize them and make sure that they are no danger to Earth. But if they are, prepared to defend us. And then the other part falls closer to planetary protection, which is understanding the potential for there to be abodes beyond Earth where life from Earth could survive. And if so, how can we make sure that when we're sending spacecraft out there, we're not contaminating those environments?
All right. That sounds pretty impressive. So how important was it when you found that there were certain solubles, in the water on Mars? Were you looking for them specifically?
So on Mars, we've been thinking for a very long time about the potential to form what are called brines, and that's just very salty water, all the way back from the 1970s. But nowadays we have all of these missions that we've sent to Mars have given us a lot of data about what the conditions on the surface are, what the weather is. And we've been able to use that in our experiments to figure out what type of brines could form there and what type of brines could stay stable and what the conditions of those liquids would be. And then the important part, is there life that we know that can survive those conditions? So in the work that I recently published, we used all of that information to figure out where could there be liquids on Mars, and for how long should those liquids last? But then more importantly, are those liquids habitable to life as we know it? And it turns out they're just going to be way too cold.
So my understanding is that the salt within the water prevents it from freezing. And is that the problem with it is on Mars?
Yeah, so you're in Pennsylvania, right? When it snows, you typically go outside and throw salt on it so that the snow goes back into the water phase, right?
Right.
So the way that works is when water wants to go from the liquid over to the ice phase, it combines in these crystal forms, right? Because water itself is this type of molecule that we call polar. One side is a little bit more positive, the other side is a little bit more negative. So like we know, opposites will attract. And so when it's going from the liquid to the solid, they line up nicely, positive, negative, positive, negative. But when you throw a salt inside there, the salt will combine with that water and will take away its ability to be polar. It no longer has a charge. So when that now water plus salt tries to go to the ice phase, it just bounces around. So you'll allow it to stay in the liquid for longer. So you reduce the temperature that water plus salt mixture will be able to stay liquid, right? And that's why when you go outside and it snows, you throw salt on it, because now that mixture of water plus salt decreases the temperature at which that combination will freeze. And it's the same thing on Mars. The salts that we're looking at on Mars, though, it's different than the sodium type of salt you throw on the snow. So that changes the temperature that that solution will freeze out, but not by a lot. It's just a couple of degrees. The type of salts that we're looking at on Mars will change the freezing temperature by tens of degrees. And that's the type of stuff that we need because Mars is so, so cold.
So if we did try to send colonists then to Mars, they would still have to bring with them their own water or try to find a way to bring the water temperature up to make it warmer?
So that's a great question. That's actually a question that NASA considers a lot because it costs so much money to take any amount of mass with you when you leave the Earth, just because of the cost of fuel and the cost of all that goes along with it. Luckily, on Mars, at the poles, there's a bunch of water ice. And as you move away from the poles, the water ice goes into the subsurface. So there'll be like ice, and then above it there might be a meter or so of soil or dirt. So if you dig beneath it, you'll hit a bunch of ice. So when we send explorers to Mars, if we want to avoid having to take a lot of water with us, we can send them to these regions where they might just need to dig to get to the ice. Now, the catch-22 there is if you do that, if you send them to areas where ice is more accessible and they just need to dig, those are areas that are typically much colder on Mars. And so you're going to have to make sure that the spacesuits that we're sending and the protection we're sending with these explorers is sufficient to withstand those temperatures.
So going down and digging into the water underneath the soil the way we have reserves of water under our soil, for example, would not work in order to water crops or anything if we wanted to try any type of farming on Mars at all.
Well, you could dig down, and as long as you brought that ice into, let's say, a little shelter you made where you're keeping the shelter, the temperature much warmer and the pressure inside the air pressure in your shelter much warmer. If you bring that ice inside there, you'll be able to have a bunch of water, and you can have your own little farming unit there, kind of like in the movie The Martian.
Oh, I didn't see that. So you would actually have to create a dome or something in which you would have an artificial world within underneath that protective covering.
Correct, yes.
That's very interesting. So what are you going to do with the newfound knowledge that you have gotten from your exploration? How are you going to apply it?
So the application of the work that we did, it affects how we can explore Mars. So in exploration of the solar system, we have these policies that dictate how we can do it. And they're international policies where all the spacefaring countries agreed to abide by. One of the important ones is called planetary protection. That policy is set in place so that when we go out exploring the solar system, we don't accidentally contaminate things with the life that we bring from Earth. Now, as part of that policy, when it applies to Mars, it means that if we think somewhere on Mars there might be liquid water, we can't go anywhere near it because there stands a chance that we could contaminate it. The type of work that we did is looking at that potential, looking at that risk of us contaminating a liquid that could have formed on Mars, a brine. And we found that when those brines form, it's far colder than the lowest temperature we've observed life on Earth to tolerate, which means that the risk of us contaminating those areas of Mars goes away, or at least gets significantly reduced. That lets us or rather facilitates the exploration of Mars. Because now instead of saying we have to stay super, super far away from anywhere where we think there's a liquid, we can approach, potentially get closer to it. We still need to be cautious, but that reduction in risk means that we could start exploring these.
And I guess it also would prevent any country then to go up on Mars and try to do any kind of strip mining, looking for any potential minerals or some of the other things that we have no longer have available to us on Earth.
That might be the case. I don't know about the...
Okay, I was just curious.
Yeah.
If you would be able to prevent people from then going up to Mars and trying to establish separate places. So if you're saying that you're a community where you don't want people to go up to contaminate Mars, or you don't want people to go up there and set up separate type of settlements, then everybody has to agree what they're going to do before they can step foot on the planet.
Correct. So that is part of the space policies that all nations or spacefaring nations abide by. It includes policies on mineral resource utilization. So if we think there's a truckload of iron on Mars or anything like that, before a nation goes out there to mine it, there are certain policies that they do have to abide by, yes.
Okay, because I think that a lot of people misunderstand that, and that if the United States went up, everything they did on the planet Mars would be exclusively to the United States. But that's not what you're saying, is it? It's a global responsibility towards what you do with your findings on the planet.
Yes, for sure. There's definitely a global responsibility there, and that's why we've set up, it's called the Committee for Space Research, which is an international committee that thinks about these things and helps the United Nations put together the appropriate policies.
Now, based upon your findings, what are you going to try to find out next?
So we explored the potential to make liquids on the surface of Mars and whether these could be habitable, right? The next, though, is we did this in a global sense. What is the global potential to do this? But one of the quickest rebuttals to this type of work is, well, what if you're on the wall of a crater? What if there's a boulder right on top? How does that change the environment? Does that change the potential to make a liquid and to make it habitable? So those are the things that we call local scale effects. So the next step in this research, now that we entered this question as a bulk, we need to look at much closer into the planet and figure out, are there any caveats to this? Are there any areas where the environment, the local environment, is just right?
Now, is the water that has a salt in it, would that taste like the seawater we have here on planet Earth?
So the type of salts that we're looking at, or the type of salts that we know exist on Mars and the type of salts that would lead to liquids, are something that I would say none of us should ever drink. These are, for example, one of them is called calcium perchlorate. It's a chemical, it's a salt chemical that's actually used in toilet cleaning, so we shouldn't drink it. I don't know what it would taste like. I would avoid tasting it.
Okay, so then you could not also go up there and try to separate the salt from the water to make it pure, the way they would do with salt water here, or if they try to separate the salt from the water to make it drinkable.
Right. So if these liquids are happening on Mars, if they're close or joined with these type of salts, if we want to use that to drink, we're definitely going to have to scrub it and clean those type of salts off.
Now, would this kind of salt water also be dangerous to try and grow crops with?
After you clean it, probably not. The types of salts there do inhibit some type of plants, but there are some plants, depending on the amount of salt, that the plants could withstand it.
Okay, I was just curious what kind of vegetation could grow on Mars. Has anybody thought about that?
So vegetation, as in life on Earth kind of type of plants, naturally on Mars, there's nowhere where plants, how we know them, could grow on Mars. You would have to do this whole making a dome with a separate environment to change the conditions to be able to grow something.
That's very, very interesting. I had never known that. So if people who are interested in what you're doing on Mars and are interested in finding out more about it, where can they find your company and you on the wide world web?
Yeah, so the University Space Research Association, which is the company I work for, their website is usra.edu. USRA manages many facilities on behalf of NASA. I work at one called the Lunar and Planetary Institute. That one's lpi.usra.edu.
That sounds very interesting. Doctor, thank you very much for joining us this afternoon and talking about the brine that you find on the planet Mars. And for those who are interested, you can hear this interview all over again at https:// World Talk Radio, right-hand side of the website, scroll down. That's where the menu is. Find Cool Your Heels. You can also hear us on iTunes, iHeartRadio, Spreaker, AMFM247.com, Google, Apple, also on Amazon, ALEXA. And before you go away and stray, Swift had this to say in 1711, "Party is the madness of many for the grain of a few." Thank you all very much for listening, and remember, stay healthy. Thank you.